We are plugging along with our review of the FRQs to prepare for the Calculus AB exam here coming up shortly. Our next type is type 4, which is graphs. So understanding calculus through graphical expressions or graphical means. The 5 questions we're going to focus on are listed here. The first one we're going to look at is 2013 number 4. That is our introduction to graphs. So with that said, this is a non-calculator problem. And so let's go ahead and go on to the example here. All right, it gives us a graph, and what I notice right away, this is always something we should look for right away, is what does this graph represent? Well, it says in the graph, it says this is the graph of f prime. But let's go ahead and read the prompt. It says the figure above, actually the figure to the right, shows the graph of f prime, the derivative of a twice differentiable function f on the closed interval 0 to 8. The graph of f prime has horizontal tangent lines at x equals 1, x equals 3, and x equals 5. The areas of the region between the graphs of f prime and the x-axis are labeled in the figure. The function f is defined for all real numbers and satisfies f of 8 equals 4. All right, for part A, it says find all values of x on the open interval from 0 to 8 for which the function f has a local minimum. So we can go through all of the work involved here, but really this is just observing a graph. Remember, to find a local minimum or any kind of extrema, we have to first find all our critical points. Well, our critical points are when f prime equals 0, when f prime does not exist, and at endpoints. What I notice here is that we don't have endpoints in part A because this is an open interval, so we don't have to consider those. Our critical points are going to be when x equals 1, when x equals 4, and when x equals 6, because that is when f prime is equal to 0. A lot of students will make a mistake. They'll say f prime equals 0 at 1 and 3 and 5 because they see horizontal tangents. That you have to be careful of because this is the graph of f prime. F prime equals 0 when f prime touches the x-axis. Now, more specifically, we are looking for local minimum. So we are looking for when the derivative changes signs from negative to positive. And we only see that occurring once here, and that's when x equals 6. So there's a local minimum when x equals 6, since f prime changes signs from negative to positive. Point values here, you're going to get 1 point for your answer with your justification. So only 1 point here. If you have the correct answer, the correct x value, but the justification is not correct, you don't get the point. So be careful on that. All right, for part B, it says determine the absolute minimum for the value of f on the closed interval 0 to 8. Now we know, there's a couple ways of approaching this. We know that there is only one relative minimum in the open interval. So the only thing that this is changing is that we have a closed interval. So now we just need to evaluate our 2 endpoints as well as our 1 critical point on the inside. But I'm going to approach it just a little bit differently. Our critical points, we talked about a minute ago, our critical points are endpoints, are n when the derivative equals 0. So we have a critical point at 0 because it's an endpoint, 1 because f prime is 0, 4 because f prime is 0, 6 because f prime is 0, and then at 8 because that's an endpoint. So we're going to find the actual values of the function at all of those points. Now, you can justify away not having to check 1 and 4 because of what I said earlier, because when x equals 6, that is the only relative minimum in the open interval. Therefore, you only have to check f of 0, f of 6, and f of 8. Regardless, you still have to figure out what f of 0 is. Now remember, to find f of x given f prime, we always want to revert back to, oh, let's just take the antiderivative. Yeah, that's nice, except for we're not given a function that we can take the antiderivative of. So we need to write our function in integral form. So this is very much like the position equation. Remember, position is equal to the initial position plus displacement. Well, f of 0 is equal to our initial condition, and in this case our initial condition is f of a equals 4. So we'd say 4 plus the integral from 8 to 0 of f prime of x dx. So again, this is kind of like our initial position plus our displacement. So we need to figure out the integral from 8 to 0. Now I don't like going backwards. It just causes my brain to think funny. So what I want to do is I want to change it so I'm taking the integral from 0 to 8. So you remember the rules of integrals that say if I flip the bounds, I flip the sign out front. So I can rewrite this as 4 minus the integral from 0 to 8 of f prime of x dx. Now from here, we could say that this is going to be 4 minus, oh, let me take a step back here. It's going to say 4 minus something. Well, the integral from 0 to 8 is the area, the net area, bounded by the curve in the x-axis. So this area, because it's above and we're going to the right, is a positive value, so that'll be 2. And then we're going to add to that this area, which is a positive value because the graph is above the x-axis and we're still moving to the right, so plus 6. And then we're going to add to it this area. Well, this area has a negative value because it's below the x-axis and we're moving to the right, so it's going to be minus 3. And then we're back up on top again, so it's going to be plus 7. And so you can see the reason that I like going, the reason I flip that, instead of going from 8 to 0 and 0 to 8, is because I can think of this area positive, positive, negative, positive. Whereas if I was going from 8 to 0, going backwards, then this would be negative, negative, positive, negative, and that just causes my brain to go funny. Anyways, we simplify this, we get negative 8. We're going to do the same thing at all our critical points. So f of 1 is going to be 4 plus the integral from, we could do this again, 4 plus the integral from 8 to 1 of f prime. But notice I already flipped it here, so I said 4 minus the integral from 1 to 8. And so now we're going 4 minus, we're only going from 1 to 8, oops, only going from 1 to 8 here. So it's going to be 6 minus 3 plus 7. And then simplifying that, we get negative 6. We're going to do the same thing on the other critical points. At 4, we get the integral, or sorry, 4 minus the integral from 4 to 8 of f prime, which is 0. If you do the work, I didn't want to express all that. F of 6 is going to be that expression, you get negative 3. And then f of 8, you actually don't need to do any work there because it gave you what f of 8 was, it's 4. And so out of all of these critical points, the lowest value of the function was negative 8. And so we'd say our absolute minimum is negative 8 as our final answer. As far as points go, you get 1 point for using your critical points. So if you said you were going to find the position at all of these, all of these points here, you get 1 point for that. Or if you went through the justification of why you're only checking 0, 6, and 8, that's still 1 point. You would get 1 point for actually finding the values of f of 0, f of 6, and f of 8, and then 1 point for your answer there. Alright, so that's part B. Let's go ahead and take a look at part C. It says, on what open interval contained in 0 to 8 is the graph of f both concave down and increasing? Well, we have to go through our interpretation, and this is where the chart is really handy. We know that f is concave down when f double prime is negative, which implies that f prime is decreasing. So we're looking for the part of the graph that is decreasing because we're looking for f prime here. Now we also want to know when f is increasing. Well, we know that f is increasing when f prime is positive. So when we go through our justification and our logic here, we want to make sure that we are taking the question, and the question is talking about f, and translating it in terms of what's given. So translating it in terms of f prime. So notice I went from f to f prime, f to f prime. So we are looking for when f prime is decreasing and positive. So we can see that we are decreasing and positive over this interval and decreasing and positive over this interval. So we'd say from 0 to 1 and from 3 to 4. So the points on this, you would get 1 point for the correct answers and 1 point for the correct justification. If your justification is not there and you just have the correct answer, they're going to give you a 0 out of 2. So you need to make sure your justification is there. It's very important. For part D, it says the function g is defined by g of x equals f of x to the third. And then if f of 3 equals negative 5 over 2, find the slope of the tangent line to the graph of g. Now this problem has nothing to do whatsoever with, has nothing, well, it has a little to do with the graph, but it doesn't have much. We are looking for the slope of the tangent line of g. So we need to find the derivative of g. So the derivative of g, notice it's going to be the chain rule here. So the derivative of something cubed is 3 something squared, right? 3 times something squared, and then we have to use a chain rule, so times f prime of x, because that's the inside there. And then we're going to plug in 3 to x to figure out what g prime of 3 is. So we got 3 times f of 3 squared times f prime of 3. We're given in the prompt that f of 3 is negative 5 halves, so that's going to be 3 times negative 5 halves squared, and then times f of 3. Well, f of 3, that's where our graph comes, sorry, f prime of 3, that's where our graph comes into focus here. We want f prime of 3, since this is f prime of 3 is 4. Now, a lot of people would say it's 0 because there's a horizontal tangent there. No, this is the graph of f prime, so the value of f prime at x equals 3 is 4. Simplifying all that, we end up with 75. So you would end up with 2 points if you got your g prime function, so 2 points for this part. My guess is they would give you 1 point for saying 3f of x squared, and then the second point for doing the chain rule correctly. And then you would get 1 point for your final answer of 75. And again, if you left it like this, the 3 times negative 5 halves squared times 4, that's full credit right there. You do not have to simplify. You can't leave it like this because that's not all numeric. That's in function notation. But because this is all numerics, you could leave it like that and you'd be good. All right, so that is the end of our introduction to graphs. So now it is your turn. We did 2013 number 4 just now. You guys are going to do 2017 number 3 on your own. It's a you do, so set your timer for 10 minutes, see how far you can get, and then go ahead and grade that using the next video, and I will talk to you later.